Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I'd like to introduce Joel Brandt, who's a PhD student at Stanford. He is graduating in a year, hint, hint, and here to talk with us about something I think is really fascinating that he calls opportunistic programming. And take it over,
Thank you,
Joel.
Gina. So good morning. Like Gina said, my name is Joel Brandt. I'm a PhD candidate at Stanford, and I'm in the Human-Computer Interaction group there. I'm also an intern researcher in the Adobe Creative Technologies lab. So the sentence I'm about to say is probably the most important of my talk. None of this would have been possible without all the help of my wonderful collaborators. At Stanford, I've worked with Philip Guo, who actually was an intern here this summer, Joel Loonstein, William Choi, and my advisor Scott Clemmer. And at Adobe, I've had the pleasure of working with very closely with Mira Doncheva and also with Marcos Westcamp as part of David Salazin's research group. And I really want to thank Gina again for setting up everything for my visit today. It's so far been awesome, and I don't expect that to change in the next few hours. So today's talk will largely be about how programmers use the web, both understanding how they're using it now and understanding how we can build tools that support that. And so I'd like to start out by presenting a vignette from one of our exploratory studies. So Jenny was working on building a user interface for a web-based chat room. So she was staring at a blank Emacs window and she said, "Good grief, I don't even remember the syntax for forms." Now, Jenny's a great programmer. In fact, she's a PhD candidate. And if she saw the syntax for HTML forms, she'd know exactly how to use them. She doesn't need to learn anything. She just needs an external memory aid. Web search makes finding this very straightforward. She searches Google for HTML forms. She clicks on the first result, and she quickly scrolls to code on the page. A quick copy and paste later, and a few typing changes, and now she's already got a mock-up of a user interface. All this took about 60 seconds, something that would have taken orders of magnitude longer in the days before the web. In short, we believe that the web has fundamentally changed programming practices. It is now feasible for programmers to build entire applications by iteratively searching for, modifying, and combining these short blocks of code. And this enables what we call an opportunistic approach to programming, where individuals interleave this web foraging, learning, and writing code. So we've defined, and actually folks at Microsoft have also defined, opportunistic programming as the type of programming that's done to prototype, ideate, and discover. It emphasizes speed and ease of development over code robustness and maintainability. Now, it's by no means the only type of programming that gets done, but we believe a large portion of the code written today is written in this manner. It's certainly done by professional software developers, and it's also done by amateurs, by designers mocking up user interfaces, by scientists writing code to run experiments, and by weekend hackers building the next generation of physical computing devices. So Scafidi, Shaw, and Myers recently estimated that by 2012, which is coming up, there will be 13 million people that do programming as part of their job, but only 3 million of these people will be called full-time programmers. So we believe that, for the most part, these other 10 million people will be primarily engaged in this sort of opportunistic programming. And we believe that there's significant value in understanding and designing for this large population of amateur programmers. Sure?
Ask questions at the end or not?
You can ask them now. Sure.
Okay. Your definition, could you just elaborate one more time? What is the definition of professional programmer?
So, I mean, I don't think that there's a strict dichotomy here. I mean, I think, it's certainly a sliding scale. I think that there's people that would self-describe as professional programmers, and those are the people that work on development teams and, sit down and roughly 40 hours a week write code. And then there's lots and lots of other people that just fall into the practice of coding. Either, they start out using Excel or, like I said, they're scientists and they say, I got to hook this thing up to this thing, and so I'm going to write some code. These people that have technical acumen that are willing to jump into development, but approach it from a very different mindset. They don't need code that works all the time. They just need code that runs once. And that, that's a perfectly valid reason to write code.
I'm just concerned, because, if you define a professional programmer, somebody who does, writing code for money, for fun, that is basically 40 hours a week. This is pretty much like their full-time job. And then you define non-professional as just, people who do that at free time. That fair definition?
I don't think that's how I would define it. I wouldn't say it's something that's done in their free time. I mean, I think for lots of people, this sort of amateur programming is done as as part of, in service of their job, right? It's sort of, I mean, another way you could draw this distinction in another domain is, you know, how things work with mathematicians, right? There's professional mathematicians, and they do math all the time, right, in whatever their area is. There's also lots of people that do math as part of their job. They do statistics. Maybe they do statistics terribly. I mean, but whatever. They do those sorts of things as part of their job. And we don't think it's weird that math is just something that everybody takes in college, right? But, you know, we're just getting to this point where computer science or programming is becoming that thing. It's a tool that people use even if that isn't their, you know, sole profession. Does that sort of clear things up? So anyway, so this observation leads to the two main researchers that I'll address in my talk today. First, how do programmers use online resources? And second, how can we build new programming interfaces that support and more importantly, amplify the role that the web plays in software development? So the remainder of my talk will be divided into two parts, addressing each of these questions in turn. To answer the first question, we conducted two exploratory studies, one in the lab and one in the wild. Our first study observed 20 individuals in the lab while they prototyped a web-based chat room. In this study, we found that the web played a principal role in all participants' development practices, and participants used the web with a varying range of intentions. To understand if these results generalized, we conducted a second study where we analyzed a month of queries to an online programming search engine. And we also saw traits in this study that suggested the web was being used for this spectrum of intentions, and found that a query's lexical structure, the way queries were refined, and how people visited page were very indicative of their different types of intentions. So in our laboratory study, like I said, we observed 20 participants prototyping a web chat room. When recruiting, we asked that all participants have a basic knowledge of PHP, JavaScript, and HTML. However, all but 2 participants rated themselves as novices in at least one of these technologies. Each session lasted 2.5 hours, and participants were compensated $99. Participants were allowed to use any resource while programming. They were told ahead of time that they could bring books or code to the session. One participant brought code on his laptop. No participants brought any printed materials, and all participants used the web. So we gave them a little bit of information. We said they would be building a web application in PHP, JavaScript, and HTML. We didn't say it's going to be an Ajax web chat room.
Okay, only because it said that this one guy brought code.
Yeah, so I wouldn't say he selected code to bring along. He brought along his laptop, which had code on it. He brought it along because he knew that he could go and look at it. Does that clarify things? Three researchers, one of them actually who was Philip, and 3 researchers observed all the participants, and 1 researcher, myself, asked open-ended questions as they programmed to get them to think aloud about particular aspects of what they were doing, specifically relating to how they were using the web when they were engaged in programming. The chat room that we asked them to build, we asked them to try and meet 5 specifications. First, the user of the chat room needed to be able to set their username and obviously post messages. Message updates needed to happen without a page reload, so obviously they should use Ajax, though we didn't use that term when telling them. Messages should also have a timestamp, and the chat history, the length of the chat window, should be limited to 10 lines. This last requirement was somewhat unique. You know, that's not how most chat clients work. But we added it so that all participants would have to write some code. They couldn't just go and get, you know, a PHP application that does this chat and be done. So here's one participant's chat room that met all of the specifications. And indeed, most participants met all of the specifications. So this table lists one subject per row and shows that shows what specifications they met. And an unfilled circle means that they started on a specification but didn't complete it. As you can see, 13 of the 20 participants met them all, and most met almost all of them. And while we don't have hard data on this because there's really no way to test it, we believe that only 1 participant could have met all of the specifications without being allowed to use the web as a resource. So, as I mentioned, all the participants used the web, but how frequently did they use it? So the Gantt chart I'm about to show spans the length of the entire study and has 1 line per subject. And participants' web usage will be shown as white bars. So that's a ton of data. And for the purpose of this talk, there's really only a few things I'd like you to get out of this chart. First, participants used the web a lot and used it throughout the entire course of the study. On average, they used the web 19% of the time they were writing code, so about 25 minutes, and they averaged 18 distinct web use sessions. Second, the length of the sessions varied greatly. Some lasted tens of minutes, like this one that's highlighted, and some lasted just a few seconds, like the one that's highlighted in the upper right. So what does the distribution of session lengths look like? Suppose we sort all of the web sessions by length and then plot the length of each session in order. Now, if all the web uses were for basically the same purpose, you might expect a roughly uniform distribution. Instead, we see a power law-like distribution. This suggests that the web may be playing very different roles in these different sessions. Indeed, when we were looking at the data...
So you didn't track what exactly they were doing in those sessions?
I mean, we watched them work, and so we tracked them in a qualitative way.
So do you know, for example, what that person did in 10 minutes versus that person that did like in 5 seconds?
Yes, stay tuned for the rest of the talk. That's what the next 10 minutes or so we'll be talking about. So when analyzing the data, you need to figure out some way of breaking down.
I don't know if you're going to go into this, but do you have 3 or 4 of your participants didn't finish?
Mm-hmm.
Is there a pattern in their web use that correlates with?
Well, actually, I'd love to talk more about this. We should maybe take it offline. I think the reasons they didn't finish had less to do with their particular web use strategies and more to do with their overall programming strategies. So interestingly, the most, I would say it's hard to generalize from 3 data points of people that didn't finish, right? But the thing that was the strongest predictor of not finishing is if they chose to start with a large body of code, like use something like a content management system like Drupal and build on top of that. So that's sort of counterintuitive, right? You'd think if they started with something that was almost what they wanted, that would be a huge benefit. In fact, we saw them make very, very rapid initial progress, right? So one of the participants that didn't finish had met, I think, 4 of the 5 specifications in 10 minutes. But that last specification, the one that we added where we asked them to limit the chat history, he spent 2.5 hours not meeting that specification. Whereas these other participants that built things up from small chunks where they understood each chunk and had an overall goal for how to complete the task were much more successful. So yeah, I'd love to talk more about that. Anyway, so when analyzing the data, we found that understanding programmer intention for each of these web accesses was key to explaining how they were using the web. So this intention is clearly a spectrum, but we broke it into 3 separate categories for the purposes of our analysis. First, programmers engaged in just-in-time learning of new skills and approaches. Second, they clarified and extended their existing knowledge to sort of implementation level details. And third, they reminded themselves of details deemed not worth remembering or not worth typing. So now I'll go through each of these intentions and talk about some key characteristics of each so that we can talk about how they differ. When participants engaged in just-in-time learning, they often copied and modified code before reading a tutorial's prose. So this is really interesting. One participant said, there's some stuff in this code that I really don't know what it's doing, but I'll just try it and see what happens. So we believe that this is because participants really require a how the code works instructions, which is very different than how to do a task instructions. And that's what tutorials typically provide. They say, if you want to do this thing, follow these 10 steps. So instead, experimenting with and breaking the code that they were provided, structured this more guided reading of the tutorial, where they could say, I don't understand this part, I need to go and read that portion of the tutorial. Next, participants seemed to be not very concerned with deep learning. One participant said, I think it's just less expensive for me to just take the first code I find and see how helpful it is at a very high level, as opposed to just reading all these descriptions in text. And finally, participants often learn new terminology from search snippet results, or search result snippets. For example, one participant began with the all-English query, PHP update page without reloading, and then saw the term Ajax in the result snippet. Before clicking on any of the links, he revised his query to PHP Ajax tutorial. So people are learning things from the snippets and taking little bits of knowledge that they have and bringing them into making their search experience better. Yeah?
So it seems like part of this learning is because the quickness of the learning is because they sort of maybe perceived that speed was important. Like, let me get out of this user study as fast as I can.
Yep. Well, we made him stay for 2.5 hours. But no, you have a very good point.
Then the question could be, what do you think? How do you think you can modify a design of an experiment to make them take the 2.5 hours and actually effectively use the 2.5 hours rather than trying to speed through the study?
So that's a really good question. Experimental design's hard. I think there's a couple of responses to your question. First off, one of the interesting things we saw in the study was that what was an effect of this time pressure. So, but sort of in an interesting way. So for a lot of participants, we'd see them spend the first, let's say, hour doing whatever part of the programming process they enjoyed and going slowly through that. So maybe they were, really a designer and liked visual things. They would spend, an hour getting the HTML right for their interface, when really that didn't matter for the results of the study. And then they would start to feel this crunch and try and get things done. But I think that actually feeling that time crunch is a pretty realistic situation. I think for a lot of people, especially people that are just programming in service of getting some other part of their job done, they want to get it done as quickly as possible. I think it's really hard to design a study that doesn't have any sort of time pressure. And I'd be happy to talk more about that if you have some ideas. So anyway, returning to these just-in-time queries, I'll summarize the characteristics we saw in each of these. And we'll build this table up for all three of the intentions as we go. So first, for learning queries, a good example query is something like Ajax tutorial. The terms in the query would almost always be English. They would spend tens of minutes on the web and do 2 to 3 refinements and click on lots and lots of results, 5 or more. They would typically visit tutorials or how-to articles, and they would copy dozens of lines of code. We'll return to this table for each of the rest of the intentions. So let's move on to clarification. First, we often saw participants use the web as a translator. One participant received an error that read, XML filtering predicate operator called on incompatible functions. So he mumbled, what does that mean? And instead of trying to figure it out because it was inscrutable, he copied the error message into his web search window wholesale and immediately found a forum post that said, this is what you have, followed exactly by the line of code he had. And then this is what you should have, followed by a corrected line of code. So he just copied and pasted that code and had no idea what the actual bug was. And things like this, I mean, this is an extreme example, but things like this were very common. Similarly, participants would make language analogies to sort of adapt their knowledge from one domain to another domain. So one participant said, Perl has a function that formats dates as strings, so PHP must as well. In these uses, participants often could not write the required code from scratch, but in all cases, they knew exactly what the code did when they saw it, which is very different than these learning queries. Finally, we observed that participants trusted the code they found in these uses, and often didn't immediately test it. This caused debugging problems when they made mistakes in adapting the code. So interestingly, the code was most of the time correct, but they introduced bugs by copying and pasting it, and for example, not always changing variable names consistently or things like that. And then they would assume that errors that they experienced were in code they wrote rather than the code they pasted. Again, let's review the characteristics of these clarification uses. So example queries here tend to contain a mix of code terms and English terms. And sometimes they'll contain code terms that aren't particularly relevant for the language being used. So JavaScript doesn't have threads, but you'll see a query JavaScript thread that will lead people to a forum post that tells them to use set timeout instead, which is a thread-like functionality. So the query terms used will be a mix of code and English. These accesses will take about a minute. They'll usually do 0 to 1 query refinements and 1 to 2 result clicks. These types of uses will take them to API documentation, blogs, forums, and they'll copy several lines of code. Finally, participants use the web as an external memory aid to remind themselves about forgotten details. In some cases, they explicitly chose not to learn things. After one participant searched for and immediately copied code, we asked him if he'd ever copied it before. He said yes, hundreds of times. And then he went on to say that he never bothered to learn it because he knew it would always be there. In some cases, web search served as web-enabled autocomplete. If they would forget, for example, the beginning portion of a method name, autocomplete wouldn't help them, but web search would quickly recover it. Here the participant forgot the exact name of the MySQL fetch array function in PHP. He searched for PHP fetch array, and the first result contained exactly the information needed. He didn't even have to click on a result. We did observe that despite the utility of these uses, they often broke programmer flow because the participant had to shift out of his current programming environment and into a web browser. So finally, let's detail the characteristics of these reminder uses.
Quick question about augment.
Yeah.
What kind of development environment did they use?
So that's a little complicated of a point. We provided for everyone Aptana which is an open source IDE for web development that provides decent autocomplete, especially for PHP. It's obviously not as good as you could have for a statically typed language. But I mean, in general, that's a problem with web programming. We also let participants install their own IDEs or development environments if they wanted to.
So if you choose another language, let's say if you choose, let's say Java, okay, or C#, and install the IDE that are targeted toward that language has a pretty good support for IntelliSense, do you think that would change?
I think, well, this actually is foreshadowing a later part of our talk, where I'll talk about building tools for development environments that bring web search into the development environment. I think it would change the results, but not dramatically, because to use autocomplete, you need to have knowledge about exactly what you want to do and how to term it still, right? So how to phrase what you want to do, which the web plays a big role in helping you do that sort of thing. And second, even if you autocomplete to a method name or a class name or something like that, that still doesn't tell you how to use that thing for these slightly higher level tasks. Connecting to a database. Just finding in your autocomplete the method that connects to a database doesn't tell you the 3 steps you need to do to connect to a database. For that, you need to either jump down into some documentation or find some example code or something like that. So I certainly think it would change the results, but I think not dramatically so. So let's go through these things for reminders so that we can contrast things. So an example query here would be something like fetch array PHP. The terms are almost always code, and these accesses generally take less than 1 minute. They usually require no query refinement because people know exactly what they're looking for, and require 0 to 1 result clicks. They typically take people to API docs or just the result snippets. And sometimes people copy no code from these accesses, sometimes they copy several. It really varies. So we learned a great deal from this lab study, but we wanted to better understand if these results generalized. So we conducted a large-scale query log analysis. We obtained 1 month of search and result click logs from Adobe's Community Help portal, which is a Google custom search engine which indexes all kinds of Adobe Flex-specific content throughout the web. As you can see from this screenshot, the search results are presented in a manner very similar to popular general-purpose search engines. The Community Help data contained over 100,000 queries from approximately 25,000 programmers. All of the queries in this data set were about the Adobe Flex framework. For analysis, we grouped these queries and result clicks into 65,000 sessions, where a session was identified as a string of queries from a single user with gaps no longer than 6 minutes. This methodology is pretty consistent with previous literature. After this, we programmatically analyzed 3 properties of each session. First, the format of the query strings, that is, whether they contain plain English, code-specific terms, or both. Second, the process of query refinement. And third, the types of web pages visited, for example, whether they went to tutorials, blogs, or API documentation. Finally, we also hand-coded 300 sessions with respect to this notion of intention I introduced earlier. Sessions were coded as either being closer to the learning or reminding end of the intention spectrum. We didn't code for the middle clarification intention, sort of due to insufficient context. Again, I'll only have time to present a few high-level results in this talk. There's a paper on this, and so I refer you to that if you'd like to see more details on the quantitative analysis. First, we found that query format predicted the types of pages visited. What do I mean by that? This table presents the types of web page visited, such as tutorials or forums, broken down by formatted queries, either code-only, English and code, or English. Each column here sums to 100%. And so the numbers present the percentage of, for example, code-only queries that go to a particular page type. So looking at each row, we see that Adobe API pages were primarily visited as a result of code-only queries. This suggests that API pages are only helpful when participants know exactly what they're looking for. Next, tutorials were most commonly visited by English-only queries. This, again, is not surprising. Participants need tutorials when they have a high-level description of their problem, but don't know how to do it. Finally, blogs and forums were most often arrived at through queries that contain both English and code. We speculate that this is because such content is most helpful in clarifying situations, where participants know only some of the specific pieces involved in solving a problem. Based on our hand-coded data, we observed that sessions on the reminder side of the attention spectrum were typically code-only queries. So this table presents a breakdown of query format by session intention. Again, all the columns sum to 100%. we see that code-only queries commonly drive reminding uses, and English and code or English-only queries drive learning uses. Third, we found that programmers rarely need to refine queries. So this stacked histogram presents a summary of the amount of query refinement that happens during search sessions. In this graph, the nth bar shows the total number of sessions that have an nth query. So the first bar contains all the sessions, the second contains all sessions that have at least 2 queries, and so on. Each bar is broken up by the format of that query. As you can see, the histogram tails off rapidly. There are an average of 1.7 queries per session, and this is significantly smaller than for the general population. The lowest published number we could find, not a lot of people publish data on this, was about 2.2 queries per session. So now if we take this histogram and normalize the height of each bar to 100%, we can get a view of how query content changes as queries are performed. Interestingly, the first queries are almost always either code-only or English-only. And as code-only queries are refined, programmers tend to add English. The proportion of English-only queries, however, tends to remain relatively constant. So this suggests that when programmers start off with English-only queries, they may not know how to make them more precise with code terms. So now I'd like to present 5 key insights that came from these 2 studies that offer some implications for tool design. First, this just-in-time learning is common, and programmers do this learning by experimenting with the code. This suggests that we should maybe create tutorials differently. Tutorials should teach how code works and perhaps provide a sandbox for users to experiment with that code. Yeah?
How the code works. Because what we figured out is that people are much more interested in, I don't know, learning how to show data in a tabular way, as opposed to data binding with a grid view control, because they have no idea that there is a grid view control and data binding they have never heard of before. So if we specify the tutorial in terms of how they would phrase it, we are much more successful, and it would only show how it gets done, but we wouldn't explain how the code works. It's just, okay, this is how your task is. And so I don't know what you mean with how the code works.
So it'd be great to talk more about the studies you've done, because we haven't explicitly looked at different types of, different ways to create tutorials and how that actually plays out. I'd love to talk about that. Our intuition has, if I'm understanding you correctly, our intuition is not so much about how to structure the intuition or purpose that tutorial is provided for. I mean, I think you're probably exactly right about trying to get people to the right tutorials, but but about the necessity of providing information about how a particular block of code in that tutorial works, so that if people experience problems with it, they can fix those problems, right? So if any code that they find in a tutorial, if they just want to follow that tutorial through step by step, great, the tutorial will be perfect for that. But most likely, they want to do something slightly different than that tutorial. And as soon as they have to change code, tutorials don't teach them how that code might be changed. So it shouldn't be that every single line in a tutorial is explained. There's lots of boilerplate in there. But the lines that people are going to need to adopt to do whatever their job is, they need to understand how those lines of code are working. So hopefully that sort of addressed your question, and I'd love to chat more about what you found. Second, we saw that copied code is often not immediately tested. So to aid debugging, it would be really helpful to demarcate which code is copied code, and then after the execution of the program, highlight code that was and wasn't executed. In fact, we saw people waste a tremendous amount of time thinking that code ran that didn't even run, or vice versa. Third, we saw that search was often used as a translator. So I'm certainly not an information retrieval expert, but perhaps we can automatically extract these synonyms for code-specific searches and use this to improve ranking. Additionally, perhaps we can automatically search the web for the content of error messages so that we can help people find bugs sooner. Fourth, we saw that programmers often choose not to learn syntax. So this suggests that we should put search inside the development environment and make current autocomplete tools sort of web-enabled. And finally, we saw that when participants refined queries, their query refinement was often predictable. For example, they would often add versions of libraries or frameworks to improve the result set. So this additional context is available in the development environment. And perhaps we could use this context that's present in the development environment to automatically augment queries so that programmers could find good results faster. So I'd like to take these design guidelines as a driver for the second part of my talk, investigating how we can build tools that support and amplify the use of the web during programming. Given the great diversity of web use that I've just described, we believe there's significant value in building very task-specific search interfaces for each of these intentions. So returning to this graph from earlier, our recent work that I'm about to describe focuses on this long tail of tasks and this clarifying and reminding end of the spectrum. Improving the just-in-time learning aspects of web use remains exciting future work for us, and I'd be happy to talk more about the things that you guys are doing in that space as well. The main insight behind the tool I'm about to describe is that milliseconds matter. Specifically, we believe that lowering the threshold to complete what are already brief but very common web search tasks would do more than just get a programmer home from work 90 seconds earlier. Instead, we hoped and believed it would cause a fundamental change in the way that web search was used during programming. So we began with the observation that tools programmers use to search and consume the web are wholly separate from those that they use to write code. The web browser and search engine have no access to the incredible amounts of context in the user's code, despite the fact that the code is intended to be read by computers. Similarly, the IDE has no notion of code provenance and instead assumes that every character that enters the editor has been typed by hand. What benefits might be realized by removing this barrier? To explore the question, we built Blueprint. Blueprint's a plugin for the Adobe Flex Builder development environment that integrates web search and code authoring experiences. So I'd like to show you, begin by showing you a scenario of Blueprint in use. In this scenario, we'll follow a programmer as she uses Blueprint to build a web application that allows people to graph and compare their power consumption. So this programmer begins by creating a project and adding some boilerplate code. The first thing that the programmer wants to do is load some data from the web. So they start by creating a load data function. And then they say, I've done this before, I have some knowledge about how to do it, and I know that there's a class involved that begins with URL. So they'll bring up autocomplete. Video control in PowerPoint is not ideal. Perhaps that's only a Mac-only problem. I meant to pause playback. So create some boilerplate code, and then starts out by using autocomplete. So it says, I know that I've done this before, and I know one of the classes involved has a name that begins with URL. So they'll open up their autocomplete and they'll say, oh yeah, URL loader, that's it. That's the class that I'm interested in using. But this is as far as autocomplete will often get you a lot of times. You'll say, okay, well great, I want to use a URL loader, but I have no idea how to use it. And this is when programmers will typically drop down into Firefox and a search engine and try and find example code. Blueprint allows you to just hit another hotkey and go and perform that search on the web without leaving your development environment. Now, the result view that we present in our search engine is very example code centric. So that's the thing that's foregrounded. So as you scroll through it here, you see code that uses the URL loader object. And if you've done this before, parsing this code is fairly straightforward. You look through it and you see several different examples that are doing different things. This one has lots of error handling, which might be nice. Another one further down here automatically loads the resulting URL into an XML object and parses it. So in this example, the programmer finds that and says, this is exactly the code I want. So they go and just select that code and they hit enter to bring it into their development environment. We provide information about where the code came from, so if they ever need to get back to the web page, they can do that. Also, how they access the code. So the programmer runs that code after replacing the URL and confirms in the debugger that she's actually getting the XML she expected. So now the programmer, so this is another common way that people enter the Blueprint user interface. They'll say, there's something I want to do that I know is one line of code, like setting a busy cursor. Right? But if you don't know the class involved in doing that, you simply can't use autocomplete to start that process. So with our search interface, you can search with plain English. Just type something like busy cursor and perform that search. And immediately you see, oh, well, there's this line of code right here, cursor manager. If you didn't know it was called cursor manager, .set busy cursor. So it's a very simple call, one line of code, and this allows you to get to that very rapidly. So the user here copies these 2 lines of code for setting the busy cursor and removing the busy cursor. So we'll see that occur here. So now when she compiles her code, she sees that she's missing an import statement for busy cursor. So sure, she could write this, but she can also very quickly return to the web and get that import statement. You could also imagine doing some semantic code analysis type stuff to try and help people get the right information. This third case shows another way to use Blueprint. So you can also dock Blueprint within your development environment. Here the user has searched for charting and is looking through different charts to get an idea of how she might want to visualize the data that came back. Now the nice thing we're able to do is, in some situations, we can pull out running examples as well as source code and present those running examples alongside the source code so that people can see what the code does. So here the user selects some code for a line chart, adapts it real quickly to bind it to the data, and in a matter of minutes there's a mocked up user interface. And you'll see that in just a second. So let's real quickly take a look at the interface. First, users can initiate queries a number of ways. They can hit a hotkey on a line of code that has a short amount of text, and that entire line of text is used as the query. Or they can select some text in their editor and hit a hotkey to use that as the query term. Or they can simply type into the query box and insert in a traditional manner. In all cases, we provide additional query suggestions to the user. Each query result has a title which is taken from a source web page, and an English description that we automatically extract, and also a link to the source web page if they want to go and see the example in context. The most prominent feature is the example code. Query terms are highlighted within
the source content, everything that you have within this video.
Yep.
This is coming from the documentation for the Flex, or is that coming from blogs, forums?
It's coming from essentially the web as a whole. I'll talk about that next, about how we service queries. But to give you a really brief answer, this is sitting on top of that exact same Google custom search engine that I was talking about earlier in the talk that indexes Adobe Flex content from all over the web. So I'll talk about that in just a second, how our particular extraction and query servicing works. In the code result view, we highlight all of the query terms, which, as I'll mention later, prove to be vitally important for people using the interface. Finally, when we're able to, we sometimes are able to extract a running example of the code so that users can interact with it and see what the code does. So now, getting to your question, I'll give you a brief overview of how Blueprint works. Blueprint consists of three main parts: the client plugin, which provides the interface you saw, our Blueprint server, and then an underlying search engine. Here, this Google custom search engine that I talked about. When a user creates a query, like chart, which you just saw, the Blueprint client takes that and augments the query with contextual information, things like the language they're using, particular versions of frameworks they're using, and sends all this contextual information off to the Blueprint server. The Blueprint server then uses some rules to take this contextual information and turn it into what we consider a better Google query. We send this query off to our Google custom search engine, and it obviously returns a list of URLs and also a list of autocomplete suggestions. The Blueprint server then parses this list of URLs, goes and looks at all of the pages, and tries to extract example code and English descriptions from those pages. This actually occurs offline and is cached so that we can do this in a real-time manner. The Blueprint server then sends all of this data along with some additional data, things like documentation pages that we know are relevant and the query suggestions we got from Google, back to the interface, which renders the examples. So I'd be happy to talk more about how we extract example code from these web pages and things like that. That's a little bit nuanced, so probably not appropriate for the scope of this talk, but I'd be very happy to talk about that stuff.
How do you verify that the sample actually works? Or that it does what it says in English?
So actually, it turns out the answer to that question is mostly legal issues. So it turns out we only extract running examples, so running Swift files in this case, because it's Flash, from Adobe web pages. We don't extract them from third-party web pages, and there's lots of good reasons for that, lots of good security reasons and things like that. So for those Adobe web pages, we have reasonable confidence that the people working at Adobe are trying to create the right running examples. Does that answer your question? I mean.
I'm just checking the assumption.
Yeah, so it's a really good point. There's all these really interesting security issues around serving up other people's content, and also lots of legal issues about serving it up. So we have an opt-in program that allows people to specify whether they want all of their code included in the search engine or just some of it. And I don't want to go into that in this talk because it's just legal stuff. It has nothing to do with the research, but I'd be happy to talk about it later.
Plug-in back to the Blueprint server saying this code was useful, this code was not useful?
So we do, I don't know if you, let me see if I can go back to that really easily. I didn't mention this in the interface. We, in fact, we do have opportunities for people to rate examples explicitly. No one does this, literally no one.
Right.
Like we have thousands and thousands of queries and thousands of copy and paste events, and 6 people have rated queries. So there's also, I think, a lot of opportunities for sort of implicit feedback. There are, yep. So like, did you leave this code around in your? Did you leave the pasted code around in your code? I mean, I think it would be huge to be able to use that information. Unfortunately, there are also lots of legal issues with that. So that's been a really interesting trade-off in doing this research. Obviously, I'm a Stanford grad student, but we've been doing it in conjunction with Adobe because there's so many benefits we get with working with a real corporation, right? I mean, we can get it out to literally thousands of users. We can build, on top of existing data sets. We can get access to logs that we would never get in academia, which is awesome. But it also means that we have substantially more legal constraints than we would if we were just a bunch of university students causing trouble. So again, I'd be happy to talk about that. I wish I could give better answers, but so going on. So the next thing I want to talk about is how we've evaluated Blueprint, and I personally think this is the most exciting part of this work. So to better understand how Blueprint changes the search experience, we conducted, again, 2 studies. The first was a comparative lab study with 20 participants, and the second was a 3-month deployment. We had over 8,000 people install Blueprint, and a little over 2,000 of those actually used it for real, which I think is a pretty normal drop-off. Those 2,000 users constructed over 17,000 queries in a 3-month span. So as with the studies I discussed earlier, I don't have time to detail all the results. So instead, I'll present the most salient findings from each of them. Our first study was conducted with 20 participants. All of those participants were Adobe employees who used Flex as part of their job. Participants were randomly assigned to 1 of 2 conditions. They would either use Blueprint or Adobe's Community Help Search Engine, what you saw before, in a regular web browser to find resources while completing programming tests. And that was the only resource they could use. All participants followed a tutorial task that was basically identical across conditions that taught them how to use the search interface they were assigned. All participants were then asked to complete 2 tasks. The first was very directed. They were asked to, just like you saw in the demo, load data from a URL, and were asked to write this code as quickly as possible. The second was exploratory. They were asked to visualize the data set that was already in their code and produce what they believed was the best visualization of that data. We limited each task to 10 minutes, and for both tasks we measured the time to the first code paste, the time to task completion, and we had independent experts outside of our study rate the quality of code produced and the visualizations produced. So in our directed test, we found that participants selected and copied code significantly faster with Blueprint than with Community Help. So this graph shows the rank order of participants' time to first paste, and the solid squares are users of Blueprint. Blueprint users average 57 seconds from starting the task to their first code paste, whereas Community Help users average just over 2 minutes. Task completion time was very strongly correlated with time to first paste. So this sort of suggests that Blueprint helps people write code faster. Additionally, and perhaps most interestingly, participants who used Blueprint wrote significantly better code as rated by an outside expert, so code that had appropriate error handling and things like this. And we think this is because Blueprint users could very quickly scan lots and lots of example code, so they were able to select a better starting example. Go ahead. Well, I mean, when people are asked to hurry, not everybody chooses the best example, right? I mean, code was pretty similar across users, and so I mean, there's probably 10 good examples of how to do this URL loading task on the web, and so if you get 2 people that choose the same one, their code is likely to turn out about the same in the end. So I think the high level picture is a lot more important here than particular data points, but that's a great point. So the results from the exploratory task were a little less dramatic. As expected, all participants used all 10 minutes, so there's no time data there, as they were trying to produce the best design they could. when those designs were rated by an outside expert, we found no statistically significant difference in quality. So it's certainly good that Blueprint didn't make participants perform worse, but we would have liked to see them perform better. And I think the biggest reasons behind why they didn't perform better were user interface bugs. So it's not particularly easy in Blueprint right now to compare multiple examples at the same time. You can't see all of the different types of charts that you could create, for example. And you can't do that very well on the web either, but we certainly don't make that task easier. And I think you can imagine interfaces that would make this sort of comparison a lot easier. So again, we wanted to understand, we had an idea that we were on the right track with Blueprint, but to understand if we were really changing how people use the web through this task-specific search interface, we needed to put Blueprint out there and see what people really did after they'd had it for a while. So we conducted a 3-month deployment. In fact, it's still out there. You can download and use it, and examined user behavior through log analysis and interviews. Blueprint was deployed on the Adobe Labs website. 2,024 users performed 17,012 queries over these 84 days. We logged queries and user interface actions, so things like copy and paste. At the end of the study, we conducted structured interviews with 4 users recruited through a special prompt in the interface. So one problem with just doing log analysis is that with enough data, you can sort of tell any story you want to, right? So the principal purpose of these interviews wasn't to gather real quantitative hard data, but instead to drive the creation of meaningful hypotheses that were really worth testing in this data, rather than just finding something because there's lots of data. We compared Blueprint logs to the logs, again, from this Adobe Community Help search engine. And I want to remind you that Blueprint uses this exact same underlying search engine, and the user populations using these two search interfaces are the same. So really the only thing that differed in these two log sets was the search interface used.
How many programmers are using these technologies, do you think? Like what percentage of overall Adobe technology users are using the search engine?
So it's actually a very surprisingly large number, and one of the reasons for that is if you search from within the application, so just through the regular help interface, it takes you to this community help search engine. And so that's how most people are arriving there. I think the interface to get to that search engine just by browsing the web is incredibly cumbersome. So I think it's very unlikely that people are arriving there by chance or by just general web browsing. I think everybody is either arriving at this through the help system in their development environment, or something they've bookmarked or something like that after once arriving at it. Or obviously people using Blueprint arrived at Blueprint through labs and through the promotion we did. Does that?
Yeah, so that basically means those 13,000 people are pretty much most or all professional Flash developers. Yeah, that's true. So we could talk more about this offline. Professional Flash developers is kind of a funny term because, interestingly, most people who write Flash professionally have no computer science training. So it's a really interesting population. But anyway, I would love to chat more about that. So anyway, now I'll present the results from our log analysis, and for each of these I'll offer this high-level insight that came from our interviews and state the hypothesis that we generated from that. And then finally I'll describe what we found when testing that hypothesis. So first, all participants indicated that the benefits of having this consistent result view substantially outweighed the drawbacks of removing examples from their original context. So specifically, we asked one person, we asked all the interviewees, but when we asked one of them about whether additional context was ever necessary, he said, highlighting of the search term in the code is key. I scroll through the results quickly and I can find code that has it, and I can understand the code much faster than I could English. So this indicates that some help is required, but really, when you're engaged in the act of coding, there's this very small gulf of evaluation to understanding if code is something you want. And a lot of the context gets in the way in these cases. So, broadly speaking, if additional context is rarely necessary, we'd expect that Blueprint searches would have significantly lower click-through than community help searches. So in the Blueprint interface, you can click through and get that context if you want to. It appears in the same window, and it's very easy to get that context. Indeed, Blueprint users clicked substantially less, with an average of 0.38 clicks per session versus 1.32 for community help. So that's a huge difference in amount of click-through. Second, many interviewees mentioned that they used Blueprint in conjunction with other ID features. For example, as you saw in the video, they would use autocomplete to find classes or properties of interest for some task that they wanted to complete. And then they would use the code generated by autocomplete to initiate a search in Blueprint. So in short, Blueprint seemed to be working sort of symbiotically with existing IDE features, each kind of making the other more useful. So how would this manifest itself in the logs? Well, one way to look at this behavior is to look for occurrences of what you might call correctly formatted code. So code that is produced by IDE features like autocomplete will be correctly formatted, having all the necessary capitalization and things like that that people might not bother to carry over to a search engine when they're typing by hand. So if such code is indeed more frequently occurring in Blueprint than it does in community help, this would suggest that Blueprint is really being used in this manner. Now, we have this nice property that because the Flex framework uses this coding convention where everything is in camel case, it's very easy to look for cases where camel case is used. So indeed, camel case words appear substantially more frequently in Blueprint queries than in community help queries. Almost half of the queries contain camel case words in Blueprint, whereas only 16% of them do in community help searches. Finally, our participants indicated that they use Blueprint very heavily for these clarifying and reminding tasks. One participant said, I can find what I need 60 to 80% of the time without having to go to API docs. Another participant mentioned that he would often use Blueprint to make sure he wasn't forgetting anything in a task he did routinely. So it wasn't about copying code. Instead, he would, for example, routinely pull up a block of example code to make sure he hadn't left out a step when his example was when setting up transformation matrices for the Flash stage. Right? So there's 3 or 4 steps you have to do in that process, and just bringing up example code, you could compare it to his code and say, oh yeah, I forgot that step, or oh, this is the right thing. He went on to say that Blueprint works well for that mid-space between when you don't know what you're doing at all and when you need help and when you don't need any help at all because you know exactly what you're doing. So following these intuitions, we believe that refinding content would be substantially more frequent with Blueprint than with community help. Because it's being used for these reminding, clarifying, and repeat tasks. Indeed, we found this hypothesis to be true as well. 12.2% of the sessions from high-frequency users of Blueprint, again, we only looked at people that had used it a substantial amount of time, as with community help, contained queries that were identical to a query from a prior session, compared to only 7.8% of queries from community help. Finally, we took a look at the top 50 queries from both interfaces. So, as you might expect, the most common searches are quite similar. 10 of the top 20 terms for each list appeared in the other list. These are searches for things like button or canvas. So this isn't particularly interesting. But what is interesting is that the relative frequencies of terms were sometimes quite different in these two search interfaces. And perhaps the most dramatic case is that of the query for alert. So queries for alert, which is the call necessary to display a simple pop-up dialog, very similar to JavaScript, were substantially more common in Blueprint. This was ranked 8th in Blueprint and 34th in community help. And the frequency of things between 8th and 34th, the frequency change is huge. So why might this be? All right. Well, first, alert statements in Flex are slightly more complicated than you might be familiar with in JavaScript. They have 3 parameters, all of which have to be set. So you have to do a number of things. It's a little more complicated. Second, alerts are most commonly used during debugging, right? And I'm sure many of you who are programmers are familiar with that. They're convenient for conveying information to the programmer and allowing the programmer to stay in the interface. So in some situations, they're much preferable to print lines or trace statements, things like that. But there are, of course, simpler alternatives. It's much easier to use a trace statement or a print line. So let's look at the result interfaces for this query. As you can see, Blueprint immediately displays the one line of code necessary to display an alert dialog right here. Someone using community help would have to click on the first result and wait for a while for the page to load, then scroll through several screens of content to find this exact same line of code, because the first result is an API page that doesn't have code until near the bottom. So we believe this is an example of how task-specific search interfaces can change the space of tasks for which search is a viable tool. Without Blueprint, users may instead be choosing to take suboptimal approaches, like using trace statements, because the cost of searching isn't worth the benefit. So in conclusion, we believe that these results show that task-specific search interfaces can cause a fundamental change in how and when individuals search the web. Moreover, we believe that programmers' increasing reliance on the web is changing the nature of what it means to be a programmer. In fact, in the future, we suggest that programming may become less about knowing how to do a task and more about knowing how to find the right answer. So thank you so much for your time today. I'd be happy to take any more questions. Thank you.
You mentioned fairly early that you saw that these opportunistic non-professional programmers, it was very important that they get to the solution quickly, less expensively. Do you actually think that's different to whatever the opposite is of opportunistic professional programmers?
Well, I think there's two things to say to that. First off, I think there are differences. But I think more importantly, professional programmers certainly engage in this opportunistic activity when they're prototyping new things and stuff like that. I think that that part of being a professional programmer means that you're often in situations where you need to make sure that you do something right, that something's done systematically, that something's done, with a minimum number of bugs in a way that's, verifiable and that sort of thing. So I think in those situations, you always want to, get your job done and go home and sit in front of the TV. But I think the trade-offs between doing something quickly and doing something right change for professional programs a lot more than they do for these amateur opportunistic programmers.
Is there research specifically about that difference?
Not that I'm aware of. So Stephen Clark and Monty Hammondtree, who are both on the Visual Studio team here at Microsoft, were, as far as I know, the first people that sort of coined this idea of opportunism in programming. And I think this is one of these things where there's lots and lots of anecdotal evidence for it, but there's no, you can't, I don't know of numbers you can point to that say, this percent of the time they're thinking about this, and this percent of the time this other population is thinking about this. I think it'd be fascinating to get that data, and it'd be interesting to talk about how to get it.
I guess it also comes down to the type of projects they're working on.
Mm-hmm.
I mean, if you're designing a class library in the .NET framework, you have to make sure that it scales, that everything is nice and good. But if you have a project you develop for a customer, and this customer has 10, 15 people working with this software solution, you don't care about the architecture. There's no need for a n-tier architecture. There's no need that your database application, that your database can handle millions and millions of transactions per second. So
I think
you just slap it together and steer it around. And
I think it's nice to think that, but rather than, I think it's more to do with people, and I think the probability that there's more opportunistic programming going on than we'd like to think is pretty high. I think most people care about getting to a solution, and yes, they know they should be caring about beautiful, elegant code, but
well, and
people want the job done.
I mean, to carry your ideas to the extreme, I think you're both absolutely right. I'm a fairly proficient programmer, and I write tons of code in this very, very opportunistic manner. Code that I would never want the world to see, because it's code that's going to run exactly one time. I don't care if my algorithm to sort this, stuff that I'm extracting from this log file runs particularly quickly, because I'm going to process this log file once, right? And that's a very different type of software development. And a very valid form of software development compared to, our traditional models. And yet we're using exactly the same tools to do those sorts of things.
If we look in this space of the opportunistic developer, they usually, the customers they serve, they have a budget of $500, $1,000, $1,500, so they can't afford to spend 10 days, 15 days to get everything right. Like, the more projects they can do, the more money they have in their pocket. There's no time for them to.
That's the same for everybody. If given the choice between taking a long time to do a task and a little bit of time to do a task, I'm always going to choose the little bit of time to do a task.
I wouldn't say so. If your customer, if I would go to my climbing gym where they have an application where they scan my badge and all they do is log when I come and I don't come. How much would the climbing gym be willing to pay for this application? $500
I think
at the
you've
most.
just switched into the professional programming realm. Like, if somebody's paying you for this kind of job, I think we're talking about different programmers now. And I would suggest that, there's this whole end user software engineering consortium of people who study the end user end of basically people who are programming a PHP website for their church, or people who are doing a spreadsheet for a budget for their boss, and they have lots of calculations in their budget spreadsheet. But they don't necessarily even know what code elegance means. They don't have any idea what testing is, or that they should be doing it. or what maintenance is, or coding for maintainability. They have very different, their goals are basically, I need to get this job done because somebody told me to do it. There's this programming thing I have to do in order to get it done. I'll do the programming thing to get it done, and then I'm done, and I never have to think about it again.
My point is, we'd like to think that people working on Windows or Visual Studio or Office don't do quick-to-solution opportunistic programming,
They do that.
and I think they do.
They do.
And even if they do it just as a, pass zero, then they kind of pick and choose from it and say, okay, now I've got to add the security hardening or whatever it is. I think they'll obviously still be using the reminder mode. The API surface is just too large to have everything.
Yep. I mean,
how often have we seen applications that you prototype, you present it to a customer, and you as a developer have the intent that, okay, this is the prototype, this should never ever be productive. Now let's make it real, and the customer says, that's good enough, it works.
Yep. Well, yeah, I mean, and Fred Brooks has great commentary about this thing. I mean, this sort of thing. I mean, the problem is that it's actually too easy to reuse code, right? That there's lots of code that was written that, if you'd built, if you were a mechanical engineer and you'd built a physical model, you would have thrown it away. Like, that's what would have happened. And it doesn't happen in software development.
Isn't it like 2 orders of magnitude more users for this plugin or something like it? What do you think would change about the kinds of research you could do?
That's a great question. I think, well, I think it would be great to be able to sort of segment the population that we're looking at into different smaller segments and understand how different people were doing things differently. So if we could look at all of the people, if you could, for example, compare, all of the people that had a computer science background and all of the people that had a design background and see how they differed, I think that would be fascinating. I think you'd need a slightly larger population to be able to do that, but you'd also need more contextual information, which we don't have. So I think that would be an interesting thing to do. I also think our most interesting next research steps are sort of parallel to the things we've done rather than in greater depth in what we're doing now. I think there's a lot of really interesting questions about how you change the editing and code execution and debugging environment, with the intuition that lots of code that comes into your editor you didn't write, right? Nobody's really thinking about how the editing process should change for this new type of development.
Yeah,
So.
I ask because there's clearly value in what you built here. So I can totally see it taking off, especially if you've made it available for more languages. And then if you architect it right, you're going to get all this data.
Yep.
As you said, there's legal and moral issues, but.
Yep. Well, and I think also, we talked about this a little bit, I think that if we could get more data on how people are using the code, I think there's tons of really interesting things that you could do with that, especially if you had a great background in information retrieval. So I think there's lots you could learn about what code examples were good to improve ranking. I also think there's really neat things you could do where if you could watch how, let's say, 10 people use this example, what things they changed. Then for the 11th person, you could say, okay, well, you're probably going to want to change these 3 literals. Out of this boilerplate, you need these 6 lines and this 1 line, but you don't need all this stuff. And don't forget this line. Everybody copied that, right? I think so. As we start to get lots of data, you could do those sorts of things. I think all that work would be absolutely fascinating.
If you also control the content piece of it, or have input into the content piece of it, that's great input to tune that. Right?
Yep. Yeah, and it's also a great. I guess I don't know if you were saying great input to tune the interface or great to tune the actual content.
Too, but I meant the content.
Okay. Yeah. Okay. Then we're saying exactly the same thing. Yeah, I totally agree. Great. Any other questions? I'd also, of course, be happy to chat about anything else offline. So, thank you so much for inviting me.